Okay, 2013 relative velocity question 2a. We're given this diagram. A is traveling towards the intersection, so is B, and at a certain instant, each of them are 90 meters from the intersection. Now you can see B is going to get there quick, it's moving faster, and the question does ask us for giveaway marks the distance between the cars when B is at the intersection. Well, you can see that B, if we write down the maths, B, 90 divided by 15 is going to get there in 6 seconds, and in 6 seconds, A will travel 6 by 9, which is 54 meters. So 90 minus 54 meters is going to give me 36 meters. So now I have this diagram that I can write. B is here, A is here, and I've got 36 meters between them. So I create a diagram here. B is going down in this direction here. We've got theta. So the velocities, well, here's my J direction and here's my I direction. So the velocity of B is going to be 15. For my I direction, it's adjacent to I, 15 cos theta times I, and we can see it's going in this direction. So that's positive, negative. So probably should have done that beforehand. So it's going in a positive, negative direction. So we're going to have minus 15 sine theta times J, and the velocity of A, well, A is going in a positive I direction and it's traveling at 9 meters a second, so 9I. So if they're at their closest, the shortest distance is 36. So that's when B is at the intersection. So what can we say then? The velocity of B relative to A would have to be perpendicular because they're at their closest, and the shortest distance is the perpendicular point. So let's get the velocity of A relative to B. It's going to be 9 minus 15 cos theta times I minus 15 sine theta times J, so plus 15 sine theta times J. So the slope then of this line would be 0, I. We have A, we have 36, we have B. The velocity of B relative to A has to be that way. So we can say that 9, sorry, I left out a 15 here. 9 minus 15 cos theta would have to be equal to 0. So 9 is equal to 15 cos theta. So the cos of theta is 9 over 15, which would make theta 53.1 degrees.